Well, good morning, everyone, and welcome into a very exciting day here at Exploring by the Seat of Your Pants because today is our last broadcast day of 2025. We started the year in Antarctica. We're actually wrapping up the year a little later today in Antarctica, and all told, we have had 365 programs this year with some of the coolest scientists and explorers on planet Earth. So every single one of those is on our YouTube channel. You can check out programs from the last 10 years, 4,000 programs with the coolest scientists and explorers on planet Earth. And I just want to say on behalf of myself, on behalf of Joe, for this whole year, it has been such a thrill having you on as such an incredible audience, both live and on YouTube. So thank you for making this possible. It is so fun to get to bring these shows to you every single day. Now, a few months back, I reached out to Jossie Bentley. She is the science media creator. You should check out all her amazing work here. And she said, I have worked with some of the coolest people on planet Earth. Would you like to have them on the show? And of course, the answer to that is always yes. And she said, well, look, I did this program called Source to Sea as part of Great Lakes Untamed. And there's this guy, Jason, and he totally rocks. And you should have him on. So I talked to Jason, and there's very few people that match me for sheer enthusiasm. I really love what I do. But Jason is one of those very special people. And today, he is going to share some of his lifetime working to understand fish, to go out on rivers, to get out on the water, to understand jumping silver carp, which is a pretty special story we're going to be featuring today. And so with all that said, I'm not going to spoil his whole story, but we are going to learn a little bit about the wonderful watery world of rivers today, some really cool fish, and I hope you are as excited as I am. Without further ado, Jason, welcome to the broadcast for the very first time, and take us away with your epic backdrop with all sorts of fish about to slap you in the virtual face.
Thank you, Jesse. Appreciate you inviting me to join you all today. All right. Whenever we go out on a river, we need to fill out a float plan so that our friends and family know where we are and what we plan to be doing. So this is our float plan for today. First, you're going to meet me. I'm your river guide for the day. I'm going to show you some of the reasons why I think rivers are important ecosystems. We'll get into some local river threats. Then we'll get to the fun part of the day. We'll get to the wild, weird, and wacky part of our aquatic friends. And then the end, we'll go over some of why I'm going to try to answer all of the questions that you need to come up with in the next 20 minutes for me. Before I share more about rivers and fish, why I love to study them, you need to learn more about your river guide for today, and that's me. I grew up near Grand Rapids, Michigan, where that orange star in the mitten is, and I lived there until I was about 30 years old. Growing up, I was a lot like the little boy in this picture. I loved spending time outside, splashing in the creek that ran near my house, and generally getting wet and muddy every chance that I could. Honestly, that still describes the 47-year-old me today too, only now I have to do my own laundry. My Uncle Steve and my Uncle Don taught me how to fish for a lot of different things like largemouth bass, bluegill, yellow perch, and salmon. Here's a couple pictures of my beautiful wife, Sue, and I. The picture on the left is us on a pier over the Pacific Ocean on the coast of California. And the picture on the right is us fishing for snook in Tampa Bay near the Gulf of Mexico and Florida. Sue almost always catches bigger fish than I do, especially when we fish on vacation. While Sue and I still lived in Michigan, I worked with a little river band of Ottawa Indians near Manistee, Michigan, and I studied stream habitat restoration in Sickle Creek and Bear Creek, focusing on a little fish called mottled sculpin in Sickle Creek. The Little River Band got a grant to remove outdated and ineffective road culverts on the reservation and replace them with more environmentally friendly open bottom bridges. So this is what things looked like before, just a couple of pipes stuck through the bottom of the road. And this is what things look like after, this much more accessible open bottom bridge. We measured changes to the stream bed and the response of aquatic insects and fish to those changes. I also tracked movement and habitat use of mottled sculpin in those newly restored stream reaches. Mottled sculpin are this adorable little fish like this one in the lower right corner here. When my wife Sue and I left Michigan and moved west, we landed in Nebraska, where I studied environmental factors affecting baby walleye and white bass in southwest Nebraska irrigation reservoirs. It was beautiful country, but it was totally different than where I'd grown up in Michigan. I worked with larval walleye only a few millimeters long, but you can see that even at that size, they still have teeth. We worked with big old trophy walleye too, like you see my friend holding here. Part of my research involved figuring out the birthday of the fish that I'd caught using daily rings on their otoliths, which are ear bones in a fish's head, like we have bones in our inner ears. Like this picture in the lower left here, each one of these rings is 1 day of life for that fish. We were also figuring out how old some of the bigger fish were using annual rings like tree rings off the spines on the fish's back. We can estimate a fish's age from these rings, and our estimate puts this fish around 1, 2, 3, 4, 5, 6, 7 years old. Sue and I then moved about halfway back home and landed in west central Illinois, right on the banks of the Illinois River. Most of my work involves long-term fish population monitoring using this big electrofishing boat. Yes, in a sense, I get paid to put electricity in the water to catch fish. I worked my first 6 years on the Illinois River from Chicago down to St. Louis, and the last 7 years I've worked on the Mississippi River from the Quad Cities in Iowa down to Hannibal, Missouri. All right, that's enough about me. Now let's learn a bit about why rivers are important ecosystems, and not just because they grow football-sized smallmouth bass like the one I'm holding in this picture here. Most of the continents on our whole world are covered with streams, creeks, and rivers. This picture shows every single stream, creek, and river in the United States, and each of those different colors represents what's called a watershed. All of the rain and snow that falls in a watershed will end up flowing into a river in that watershed. This big pink watershed in the middle of the country is the Mississippi River's watershed. And with all of the creeks and smaller rivers that flow into it, the Mississippi River's watershed touches part or all of 32 different U.S. states and 2 Canadian provinces. Those U.S. states include where I live in Illinois, where that white star is in the middle. Rivers are really special ecosystems, and they provide people with a lot of important services. Rivers help provide flood control. Rivers allow us to transport and ship a lot of the stuff that our country needs and the things that we buy. Rivers give us clean drinking water and healthy fish to eat. And rivers give us recreational and cultural benefits too. Rivers give us ways to move a lot of stuff around. River barges haul a lot of material like coal and sand, and they also haul shipping containers for all of the stuff that we buy online. I know this presentation is supposed to be about science, but I've got a math problem for you to help me solve. Each river barge can carry about 40 semi-truck sized containers, and towboats can push up to 20 barges at once. How many containers can a towboat move at one time? 800. One towboat on a river can move as much as 800 semi-trucks. That is a lot of Christmas and holiday gifts from Etsy and Amazon, isn't it? In addition to moving cargo around, rivers also give us most of our drinking water. Did you know that in the United States, 2/3 of our drinking water comes from rivers and streams? 2/3 of it. In addition to giving us clean drinking water, rivers also give us healthy fish to eat. Sue and I like to eat fish at least once a week. We also benefit from the environmental value of river ecosystems, which are even more important than all the things and services we as people get from rivers. The value of complex and amazing animals that make up these river ecosystems. I'll start with a few of my favorite invertebrate animals, those that don't have a skeleton inside. The top picture is a handful of freshwater snails. The bottom left picture is a really pretty sulfur mayfly. And the bottom right picture is a pile of freshwater mussels. There's also a lot of vertebrate animals that are in river ecosystems, including river otters, frogs and toads, turtles like this great big snapping turtle, and bald eagles and other birds. Now we get to talk about a few really neat fish that we find in river ecosystems. This fish in the top left here is called a sauger. They're related to walleye and yellow perch. If you live in the Midwest and you've ever had a scored buffalo sandwich, my friend Andrew is holding a black buffalo. That's one of 3 species of buffalo we have here in Illinois: smallmouth, bigmouth, and black buffalo. My friend Frankie is holding a 50-pound flathead catfish that she dipped out of the river this spring when we were down by St. Louis. This fish on the bottom left here is one of my favorite species. That's called a blue sucker. And if you look at all of these little bumps around his lips, they're packed with nerve endings and sensors. Those are called papilla. If you imagine sitting in your living room and you've got a bowl of popcorn in your lap and you're trying to get that one last piece of popcorn and you're poking at it with one finger, you're going to have a hard time finding it. But if you use all 10 fingers and try and get that last piece of popcorn, it makes it a lot easier. Well, that's what blue suckers use all of these bumps around their lips for. They're packed with nerve endings and taste buds, and they use them to find food on the bottom of the river. This fish in the bottom of the middle here is called a short-nosed gar. That's one of 4 species of gar we have in Illinois: short nose, long nose, spotted gar, and even alligator gar. This fish on the bottom right is probably one of the first fish that many of you have caught if you went fishing with your mom or your dad or your grandma or grandpa. That's a bluegill. That's our state fish here in Illinois. All right, so that's a little bit of information about why I think rivers are important. Now I'm going to introduce you all to the Illinois River and some of the threats that it and other local rivers have. You know, I have this section titled Local River Threats, but I would say that most rivers across the USA and even around the world have very similar problems. This is a map showing the Illinois River and its watershed. The Illinois River is about 280 miles long, and it flows from near Chicago, Illinois to St. Louis, Missouri. Its watershed is almost 30,000 square miles, and it actually begins up here in southeastern Wisconsin and over in northwestern Indiana. We're going to learn today about 2 big problems that the Illinois River and other rivers have, and the first one is water pollution. How many of you have been to Chicago? Chicago has a really big population, almost 2.7 million people, which makes it the 3rd biggest city in the United States. Only New York and Los Angeles have more people. And that is a lot of houses and hotels and schools and factories and stores and businesses, which means there's a lot of people flushing toilets and doing laundry and washing dishes, and a lot of water and other resources that get used. Some places like factories can dump a lot of chemicals right in the river, like we see in that top picture. All of those people in Chicago also make a lot of garbage, and not all of that garbage ends up in trash cans or recycling bins like it should, and it can wash into rivers when it rains. Did you know that plastic from pop bottles and water bottles and Gatorade bottles is one of the worst kinds of water pollution that there is? Did you see these 2 ducks right here trying to find food and all of that garbage? The Illinois River can also get these green algae blooms like here on the right in the summer when the water gets warm because there's so much water pollution in the river sometimes. All of that water pollution and litter can hurt and even kill fish and other animals that live in rivers. If there's too much pollution, the water isn't safe for them to swim in, and they can get sick and even die. 100 years ago, the water pollution from Chicago was so bad in the Illinois River that all of the fish and mussels were gone for over 100 miles downstream of the river in Chicago. Water pollution can also be bad for us as humans when we want to swim or kayak or eat fish from the river. If the water pollution makes the fish sick, sometimes it can make us sick if we swim in it or if we eat fish from a polluted river. Most of the Illinois River and rivers across the U.S. are okay to swim in or eat fish from nowadays. But 100 years ago, when all those fish and other animals died because of water pollution, a lot of people along the river got sick too. The water pollution in the Illinois River has gotten a lot better in the last 50 years, thanks to laws like the Clean Water Act passed by the federal government that limit how much water pollution can be in the river, and also because of how good the water treatment plants are around Chicago, like I show in this picture here. Water treatment plants are expensive to operate, but they take out a lot of bad stuff and reduce the amount of water pollution that goes into our rivers. We still have some problems with water pollution in the Illinois River, but it's not nearly as bad as it used to be. The second big problem we're going to learn about in the Illinois River is invasive species. The Illinois River is home to a couple of dozen invasive species like red swamp crayfish, round gobies, weatherfish, silver carp, which you can see in the picture and behind me, and goldfish. These invasive species all cause a lot of different problems for the native species, the ones that are supposed to be here. How many of you have heard of the Sharknado movies?
Me.
Well, you know how scary a Sharknado can be, but can you imagine being stuck in a Carpnado like this one? Obviously, the invasive species I work with the most is those silver carp jumping out in the river, right in the middle of this Carpnado. A lot of the people I work with do different research with silver carp and other invasive species to understand the effects they have on parts of the ecosystem. Fortunately for me, my big workboat has a metal fence on the driver's side to help protect me, and my steering wheel and throttle handle too. I am protected from silver carp that might jump into my boat and crash into me or the steering wheel or the throttle, and send us places on the rivers we don't really want to go. This graph shows the exploding population of silver carp in the Peoria area of the Illinois River from 1999 to 2021. We have carp abundance along the side on the y-axis and time in years across the bottom on the x-axis. Now, there weren't any silver carp in the river until 2004, and then you can see their population just exploded after that. I mean, they don't actually explode, but that might be a pretty good way for us to get rid of a bunch of them in a hurry. Actually, the best way we can get rid of a bunch of them in a hurry is to eat them. Rivers give us a lot of healthy and nutritious native fish to eat, and those invasive silver carp that jump out of the water and into your boat are actually really tasty and nutritious for us to eat too. When we look for silver carp in restaurants or in the store, it's called kopi, like you can see on the package here. Sue and I eat kopi a couple of times a month, grilled or fried or baked, and it's delicious, high in omega-3s, and very low in contaminants. The best part is you don't even have to be a good angler to catch them because they literally jump right in your boat, almost like they want to be eaten. All right, so that covers some of the bad news about some of the threats that our rivers face, but now it's time for me to share the fun stuff, all about some of the wild, weird, and downright wacky facts about some of our watery friends. We'll start with this little friend. It's called a water scorpion, which looks a lot like an underwater walking stick insect. This particular friend we found on Pool 17 of the Mississippi River near Muscatine, Iowa last summer. And those aren't antennae coming off of its head right here. Those are actually its front legs, which it uses like a praying mantis does to grab food. But that's not why it's featured first in this wild, weird, and wacky segment. Unlike scorpions that live in the desert, that is not a stinger on its rear end. That's a butt snorkel. These insects are air breathers, so they rest with their hind end pointed up towards the top of the water, with the tip of this tube sticking up above the water's surface, so they can stay underwater and hunting food for a long time. Next up are these animals right in the middle of the picture. Now you may be saying to yourself, this guy's crazy. I can't see any animals in that picture. It's just a bunch of rocks. And you'd be right about the first half. I am a little crazy, but there are animals there, and there's 7 of them, in fact. It might help if I circle them for you. They're called caddisflies, and these are babies, kind of like caddisfly caterpillars that haven't grown into butterflies yet. They don't actually turn into butterflies, but they go through the same kind of metamorphosis. These caddisfly babies, which we call larvae, live underneath rocks and logs and rivers, and they actually make that little tiny tube that they live in out of pebbles that they glue together with their spit. There's other species of caddisfly larvae that do the same thing with little bits of wood or plant stems, other species that use sand, and still other species that just crawl around without even making a tube. This is an example of an adult caddisfly, but I don't think they're nearly as interesting as their babies are. Moving on from invertebrates to fish, one of the really neat fish that's found in rivers and lakes all over the US and parts of Canada are bowfin, which are also known as dogfish. One of the reasons they're such a neat fish is that the male bowfin's mouth and fins turn this bright turquoise color when he's looking for a pretty girlfriend. He looks like me when I've been eating a blue raspberry blowpop. And the brighter blue that his mouth and fins are, the healthier he is, which means he'd make a really good boyfriend, or husband in my case. This fish is called a high-fin carp sucker, and it's one of our native species. Yes, the fin that's on his back is supposed to be that long, hence the name high-fin carp sucker. Fisheries biologists aren't entirely sure why that fin is so long, but it may be to help these fish identify areas in the river with less flow, so that they don't spend as much energy staying in one place. They use it like an antenna. And that may be for the same reason as our next fish, which is one of my favorites. That fish is the shovel-nosed sturgeon. And if you'll indulge me a little bit of a detour, sturgeon are a global family of long-lived fish species, with some living as much as a century. Some sturgeon species get huge, like beluga sturgeon in Russia, growing historically to more than 20 feet long and weighing more than 3,000 pounds. That's as big as the boat that I drive. In North America, the white sturgeon lives in the Pacific Northwest from San Francisco north up into British Columbia and can grow to be more than 12 feet long and weigh more than 1,000 pounds. The shovel-nosed sturgeon is the smallest and shortest-lived member of its family, but it can still live more than 40 years. Most sturgeon species around the world are either threatened, endangered, or already extinct due to overfishing for the caviar industry and habitat damage due to dams. Larger and older shovel-nosed sturgeon, like the one I caught earlier this year while fishing with friends in northern Illinois, have a tail that looks like a normal fish tail. But when they're smaller and younger, the top ray on their tail fin has this elongated filament that hangs off like a whip and is absolutely packed with bundles of nerve fibers. One scientific study showed that when young pallid sturgeon, which is a different North American species with a similar tail whip, when those fish were exposed to different river flow conditions, they'd hang out behind tiny sand dunes on the bottom of the river with that tail whip up in the current, trying to find the best spot to rest. Smaller shovel-nosed sturgeon just don't have the muscle mass or the energy reserves that big shovel-nosed sturgeon do, so they need to conserve as much energy as possible, and this tail whip seems to help them do exactly that. Now, most tail whips I've seen are only a few inches long, maybe up to 3 or 4 inches on a 20-inch long fish. But last spring, a friend of mine caught a shovel-nosed sturgeon on the Mississippi River down by Hannibal, Missouri, with a tail whip that was more than 8 inches long. And that was on a fish that was barely 12 inches long. Literally 2/3 of its body length was that tail whip. That is by far the longest whip that any of my friends who work with shovel-nosed sturgeon have ever seen. Shovel-nosed sturgeon show up again on my next slide, this time next to paddlefish, which are their fishy cousins. And if you look closely at a paddlefish's paddle, which we call a rostrum, and their gill flap, and also the head of most sturgeon species, you can see these little blotches of color. You see all these little blotches on the rostrum. They almost look like little flowers, and then all along the edge of the sturgeon's snout here. Those are called ampullae of Lorenzini, which is a really fancy way to say it's a network of jelly-filled electroreceptors or sensory organs found in cartilaginous fish like sharks and skates and manta rays and stingrays. That allows them to detect weak electrical fields in the water, helping them with hunting and navigation. So the paddle and the gill flap of the paddlefish is basically a flat antenna studded with tens of thousands of sensory cells that detect electrical signals produced by the plankton that paddlefish eat. So sturgeons, which are cousins to paddlefish, have them too, and both fish use them for navigating by sensing subtle changes in the Earth's electromagnetic field. This is a picture of our technicians Tova and Julie holding a big paddlefish on the Mississippi River over by Keokuk, Iowa. And this next fun fact about paddlefish is something I only learned myself back in September. They have a third eye. And I don't mean in the metaphysical sense or in the weird mutant sense because they live next to a Springfield power plant like Blinky the fish from The Simpsons, although you can see the Keokuk power plant in the background of the photo here. It's also known as a parietal foramen, and it's a space between the two bones of the upper skull, covered by thin skin and cartilage that forms a window that lets sunlight directly into their skull, allowing it to experience daily and seasonal changes in sunlight direction and intensity. Now, third eyes like this were very common and a lot bigger in the dinosaurs that walked around during the Jurassic and Cretaceous periods, but they're not prevalent in smaller animals of our modern times. They can still be found in some sharks, frogs, and lizards, but in those species, it's a tiny, barely noticeable structure. In paddlefish, it's really, really big. You can see it like this. It's believed that this third eye in paddlefish influences various biological processes like migration and spawning that depend on annual changes in the seasons, and thus in light levels, and that regulates when they happen for paddlefish. All right, that is a lot of wild, weird, and wacky facts about some of the fish and other animals in our rivers, and I hope that was as much fun for you to hear as it was for me to put together. With whatever time I have left, Jesse will let me know. I'm happy to answer any fish or river-related questions that you have. They can be questions about me, about where I work and what we do, about fish, or about rivers, or about anything else, and I'll do my best to try to answer them.
Jason, thank you so much, man. I can't believe you snuck in caddisfly larvae, which are one of my favorite things in all of nature, and Blinky the fish, which has never appeared in the history of Exploring by the Seat of Your Pants, but was my childhood in a nutshell. So thank you so much for that. If you can see us, great. If you can't, you need to come out of screen share, by all means, pop out of that. We can have a bit of a conversation. We've already got a bevy of questions, and please do keep them coming in on YouTube, folks. Ms. Van Bellois' class wanted to know if there's a criteria for deciding what makes something an invasive species. Like, how do you sort of decide that?
So there are different levels to that, and I'll try and answer it in sequence. So there are things that are not native. For example, rainbow trout and brown trout are not native to Michigan, which is where I grew up, but they're not necessarily invasive. For something to be considered invasive, it has to cause harm or outcompete the native species, the species that are supposed to be there. So there are things like ringneck pheasants, or like I said, brown and rainbow trout that are not native to North America or native to the parts of North America where we put them. We as people tend to move a lot of stuff around that we maybe shouldn't. But in order for something to become invasive, it has to take over and swarm in the rivers like the fish you see jumping behind my head.
Fantastic. Thanks, Jason. We cover invasive species in a lot of our programs. So if it's a topic of interest to you, you can absolutely go back through our programs. There's a lot of really great resources on it with like Nature Conservancy, World Wildlife Fund too. So this is a big topic and of concern to a lot of biologists. So I'm really glad we started with that. Jason, you had a picture of a giant goldfish that looked vastly, vastly larger than the ones I had in my tank as a kid behind me. Why is the goldfish that big? Is that just what they all get to, or is that some mutant monster goldfish? What's the deal?
So the reason that goldfish was so much larger than the ones that you see, it's the same species, but fish, when you put them in a fish tank or in a fish bowl, they tend to grow as large as that container will allow, and then they stop growing. They don't want to outgrow that environment. But if those fish are either produced in the wild, or if you let them go, which is not a good idea, please don't let your goldfish go.
Yep.
Then they grow much, much larger because they have a lot more resources available to them and a lot more space to grow like that.
Yep. I'm really glad we got that question because I've seen some giant goldfish in person, and it's so freaky to see something that you're used to being this big be this big. It's totally there's no parallel for it that I can think of in life. So it's a really cool question. All right. We've got a class that lives near a bunch of farmland, and so they've got agricultural runoff. It's getting into the water. It's getting into the rivers. Can a river ever recover if you've got those sort of pollutants, I guess, going into the watershed?
Yes, rivers and a lot of other ecosystems tend to be resilient. Now, when we use the word resilient, we tend to think about, people. People are strong. People are resilient. We can overcome challenges. We can overcome stressors. But rivers and other ecosystems can be resilient too, but oftentimes they need our help. And in agricultural watersheds like the one that those students live in, things like riparian buffers, which are natural strips of vegetation, whether it's grass or bushes or trees along creeks and rivers, can help to filter out some of those agricultural chemicals, whether it's fertilizers or pesticides or herbicides that can affect water quality. And what those riparian buffers do is help to filter out some of that and put it into plants and trees and grasses rather than directly into the rivers and streams and creeks.
I like when we get questions like this because it's something that, again, comes up in a lot of our broadcasts for a variety of ecosystems. And I highlight that the Chernobyl disaster site is like a huge nature preserve now. Like it's an area that people are kept out of, and there's tons and tons of wildlife, one of the most diverse areas in all of Europe because people have been left out. So, you're looking at how long it takes something to recover, but ultimately most things can recover from pretty much everything if you just give them time and space to do so. So thank you very much for that question, guys. You talked about something near the beginning of the talk, which is one of my very favorite things in all of science, which is otolith. So this like ear bone that allows you to chart the age of something. Do all fish have that? Is it always sort of on a certain same time frame for each fish, or is it different for each fish what each, I guess, ring represents?
So yes, otoliths, like I mentioned when I was presenting that, are like the inner ear bones that we have in our heads. They're structured the same way. Most fish, let me answer that question. All fish have otoliths. All fish that I know of have otoliths. And all of them grow similarly. Now, their shapes are different depending on the species of fish that we're thinking about. But most fish species that I know of, especially the temperate fish species in North America, you can harvest those otoliths. You have to kill the fish to get them out, which is why we sometimes use other structures like the spines on that walleye's back, the pictures of the spines that I showed. But those otoliths, they lay down daily rings until the fish gets old enough that they start to lay down annual rings. So that's one way that fisheries biologists like me can estimate the age of the fish is that we get those otoliths out of the fish's head, and then we can section them, cut little bitty slices out of them, like you're cutting up a roll of sausage or a hot dog. And once you do that, you can view them in cross section, and then you can start to see those rings like the rings on a tree.
Super cool. I know from our coral reef programs too, coral do something where you're able to assess the age of them too. Like the fact that any creature that's living of all, plant, animal, whatever, has something where you can chart the age through time is so cool to me. And I love every time we get the chance to bring it up. So thanks for the question, guys. You talked about your electro boat. Is there a danger to you from the boat? And in fact, just broadly, but we get this question as well, is there any danger you have when you're out in the field? Anything you need to prepare or worry about?
I'll start with that last question first. There are a lot of things that can be dangerous when we go out in the field. If you can't swim, falling in the water could be dangerous for you. Driving on the river can be dangerous because there's other boats, and then there's logs and rocks and navigational buoys and barges and things like that. As far as putting electricity in the water, I don't recommend anybody put electricity in the water unless you've been trained and know how to do so. Now, the way that physics works is if I am in the electrofishing boat and I turn the electricity on, I am safe because I am in the boat. The fish are not safe. The silver carp that you can see jumping behind me, they don't like the electricity in the water, so they jump out of the water to get away. Most of the other fish species that we encounter in the water, they just kind of roll over and swim towards the boat. It's a process called taxis, like taxi, like getting a taxi if you go to the city, and then tetany. So taxis means they swim at our boat. Tetany means we kind of knock them out a little bit so we can get them into the boat and sample them safely. Now, if I were to put my hand in the water when the electricity is on, I would get zapped just like the fish do. So that's one of the things that I tell, especially new people on my boat, is don't touch the water when the generator is running.
A quick follow-up on that. Has anyone done that while you've been on the boat? You don't need to name names, but is that an experience that you've had in person or no?
That is an experience that I've had in person.
What happens to you when you do that?
I've been sticking a penny in a light socket. I don't recommend you do that either.
No. a lot of lessons for our audience. Thanks, Jason. One of our teachers, their son got his first boat, and it's 6 horsepower. What is the horsepower of your boat? How much more powerful is it?
The big boat that you saw in the pictures that I showed has 150 horsepower. My boat is 24 feet long and it's made of big, heavy aluminum. We carry a lot of water and a lot of equipment on that boat that's also really, really heavy. So I need 150 horsepower to get me up and going.
Very good question. Thanks, guys. We've never had a horsepower question again in our history. We're killing it with new questions, guys. We highlighted this when you talked about sort of eating the silver carp, and just in general, I love this question. We have not gotten it yet, but is fishing sustainable? Like if people see fish in a grocery store, fish at a restaurant, should they eat it? Is there anything that they should look for to maybe pick better fish when they're doing that?
That is a very good question. One of the things that I recommend doing is catching your own fish and learning how to clean it and eat it. But yes, there have been a lot of international changes to try and make commercial fishing, which is what we call it when people are catching fish to then feed to a restaurant or feed to a grocery store. Commercial fishing, trying to make that much more sustainable. Things like cod, Atlantic cod, have been overfished to the point where there are severe restrictions on them. Things like lobster in Maine, things like rockfish, which is sea bass or striped bass. There are a lot of things that we have people have over harvested to the point where we can't fish for them anymore because it wasn't sustainable. So if you can try and find sustainably sourced fish, whether that's locally sourced or regionally sourced, oftentimes that's a better decision for the environment than something that isn't sustainably sourced.
I love when we get this question, and so I just really did want to highlight it for everyone today. I will recommend too, this has been featured in a lot of our programs. In the United States, you have the Marine Stewardship Council, so MSC certified, and you'll see that on fish products at restaurants and grocery stores. In Canada, we have Oceanwise, and this is when you have experts like Jason, like people who really know what they're doing, that have gone out and done research for you to make sure that the fish you're eating is not something that they're going to wipe it all out in the next 10 years. It's something that's going to be there in hundreds of years, thousands of years, because we're managing it in an effective way. So I really encourage you to look for those. It's not a perfect system, but it's better than necessarily doing that research yourself. So thanks Thanks for answering that, Jason. That's great. Big question. Could be really easy. Could be really hard. What is your favorite fish? No pressure.
That is a hard question. It's one I get asked a lot, and I'm going to say it depends. I have a lot of favorite fish that are really, really small and really, really cute. I have a lot of fish that I like that are really, really big and really fun to fish for. My absolute favorite fish, boy, if I had to pick.
No. Da, 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 da. You don't have to pick. I mean, there's a few that jump out.
So I mentioned when I was giving a presentation about blue suckers, the one with all the fingers around his mouth. Those are some of my favorite fish because they are specifically engineered to live in rivers. Lake sturgeon, blue catfish, some of the really, really big, really, really river specific fish that live a long time and grow a lot. They are some of the only animals that I know that probably know the river better than I do. And that is something that I really respect.
Great answer. Very tactful. No fish are insulted by your answer, which is very key. A quick follow-up to this. Have you ever seen river monsters? I'm just curious. I have actually never seen an episode of this, but as someone who's such a fish, yeah. And
I don't like the name monsters because that tends to inspire fear, but I do appreciate what we call charismatic megafauna. Those really, really unique, really, really big animals.
I'm putting this on screen because the topic, a phrase that every biologist knows and every big nature nerd knows, but your general public does not. So I'm like a reptile charismatic megafauna guy, like the leatherback, reticulated python, saltwater crocodile are like my favorite things in the world. So one of the keys in conservation actually is that so much investment goes into protecting charismatic megafauna that we can forget about these smaller creatures, these lesser creatures that exist in other habitats. So it's been this big shift in the last few years to be like, wow, some of these small things really underpin the whole ecosystem. It's really important to protect them too. But I'm with you. The big guys are kind of awesome, especially sturgeon. The fact, like, everyone should go look up sturgeon around the world because they're such a freaky dinosaur looking thing. And they're truly, trually amazing. Jason,
I've got one buried in my slide. If I can share that screen again.
Great. Come on back up. Yeah, go, man.
Let's see if I can find it. Yep,
there's
me. Let's go to the next slide. That one there.
Look at that fish. So this actually segues really nicely into the next question. Is that the biggest fish you've ever caught, or is there a record holder?
That's why I have it buried in there. That is the biggest fish I have ever caught, and that was just a couple of months ago back in my beloved home state of Michigan over by Detroit.
Way to go. And at night, like, why are you fishing? Do they only come out? What's the deal?
We fish at night because sturgeon are active 24 hours a day. I mean, not individual fish, but as a species, they're always swimming around looking for something to eat.
Yeah.
And there's just a lot less boat traffic at night.
Yeah. When you pull a 90-pound fish out of the water, do you hurt your back or arms or anything else? Like, that seems like quite no offense to you personally. I'm just asking, like, that seems like a huge animal to pull out the fighting you back.
That is a huge animal. It took me almost 30 minutes to reel that fish in.
Wow.
And yes, Jesse, I hurt from the back of my skull all the way down past my rear end to the back of my knees. Because I would pull and the fish would pull back, and then I would pull and the fish would pull back. And if you do that for 30 minutes, imagine tying a fishing line to your dog and letting it run around the yard for half an hour. You're going to be beat up when you're done.
Yeah, my dog, who's about 60 pounds, ran at full speed into my calf the other day, and I've been limping since then. So I understand completely. Although your smile in this picture, we'll keep that up. That's our takeaway. Never mind the pain, worth it for the magical fish. Oh, Jason, time flies and you're having fun, man. We are nearing the end of the broadcast. Is there any final message you want to leave us with about the rivers that you get the chance to be on, about these amazing fish? Anything before we say goodbye?
I'll leave with that question that was asking about pollution earlier, and I'll leave you with that word, resilience. Rivers and the fish that live in them are incredibly resilient organisms. Rivers are amazingly resilient ecosystems, but a lot of times they need our help to be able to be resilient. I have enjoyed giving this presentation. I have enjoyed the career that I've had learning about fish and in rivers, and it's something that I look forward to doing for a long, long time.
Well, we certainly look forward to having you back to share more amazing river stories. Thank you so much, Jason. This has been so much fun, and just wishing you a very Merry Christmas. Thank you for being our second last person in the entire year of Epic Broadcast. And Folks, we'll wrap up there. Have a lovely holiday, and bye for now, everyone. Thank you so much, and see you soon. Farewell.